So what is up? This is Jordan the Hollow Man, and today I have for you a Minecraft calculator. Now this is all in binary, but as you can see, it is fully functional, and 3 minus 1 equals 2. Or you can come over here, put it in addition mode, and 3 plus 1 equals 4. Now this only works between the numbers 255 and 0. So if you try to add all these numbers together, so that's 255 plus 1, it'll give you an error output, and it'll just basically saying this output isn't right, it cannot display the output because the number's too big or too small. This has addition and subtraction, I think I already said that, but it also tells you whether A is less than B, A equals B, or A is greater than B using a comparator. This is an ALU, or an arithmetic logic unit, in a CPU of a normal computer. That is how this circuit is based. That's how I got all my information on what gates to use to make this. But that's the interface. Now let's look at the brains. So this is the brains. In red here I have the adder, in the yellow is the subtractor, and then over here in red is the comparator that tells it whether A is greater than, equal to, or less than B. The thing about using this setup, I got halfway done, realized there was a much easier way, so I'll go show you that. Looks like it's going to be night. Let me just... Right there, gotta keep it bright for you guys so you can see. But this one only compares the first bit of information. So it will compare these two, see which one's greater than the other, basically which one's on, or if both are on then they're equal, or if they're both off then they're equal. Then the next bit will compare the next two vertical ones. The thing is, if this one is saying that A is greater than B, and this one is saying that A is less than B or A is equal to B, then this one needs to take priority, saying that A is greater than B. I have a book over here in this chest if you want to download this world, and you can read that for yourself if you'd like. Over here I have the one bit of the comparator, one bit of the subtractor, and one bit of the adder. And then these are basically just stacked on top of each other, or next to each other, 8 times over to get this 8-bit system. What else was I going to show you? Down here is the subtraction output. This is where all the subtraction goes, like when you use the subtraction. And this is where the output comes back to the interface. Right here it splits it into 2. This will go to the interface, and this will actually go to my makeshift comparator. So if any of these are on, it will power this, which will then come up here and power this block, which will turn that off. So it's a NOT gate right here, which will then come over here and say that A is equal to B because of this NOT gate. If this is on, A is not equal to B because there's a subtraction output. But if there's no subtraction output at all, that would mean that both of the numbers are the same and it's outputting 0. So A equals B then, which would then go up here with the corresponding light. with a subtraction, if you try to subtract a number, I'll actually show you. If you come over here, and if you try to subtract a smaller number from a bigger number, you'll get an error output, of course, but it will output a signal out here, which is then carried over here. This is a selection system for the error output, because you can have actually right now there's an error output on the subtraction, but there's not on the addition. Now if I have it in addition mode, it would still be outputting an error from the subtraction. So I put this in place, this little selection, so that when there's a signal coming in saying we're in subtraction mode, then it will allow this signal to go through. But when there's a signal going saying hey, we're in addition mode, it will not, or it will allow a signal out through here but not over here. Now this is the subtraction error output line over here, and that goes to here saying that A is less than B, and that lights up the corresponding light. This little system right here, this is a NOR gate. This is saying that if neither this or this have an input into here, it will give an output. So basically, if that's not lit up and that's not lit up, then that has to be lit up. If A is not less than B and A is not equal to B, then A is greater than B. With this little selection system over here, I also have a little book on that I wrote. You can read through that if you want. And then down here I have it's the same concept as the selection system over there, just more stacked, I guess. There's 8 of them right next to each other, and then there's 8 for the subtraction as well. These are actually for the subtraction down here, and here's the 8 for the addition, so that it's not trying to output both the addition and the subtraction at the same time. That whole system is so you can choose which one you want. Over here I put some gates that I used, the vertical AND gate that I made, and then a normal AND gate, an NAND gate, an OR gate, a NOT gate, and then an RS NOR latch, which if it's powered over here, it'll stay powered over there until it's powered on the other side, then that will turn off. Those are the things that I used, and this is my creation. I'll put a world download in this description, and I'll have basically a bibliography down there as well. So if you guys want more information on this, you can go look at those sites and those videos. But other than that, have a good day.